Hello everyone, welcome to our pre-calculus lesson 21. In this lesson we will discuss some very basic thing about the quadratic functions. We are going to start actually quadratic functions from today. So let's begin. First, for our first class we have this in our agenda. These are the things. Quadratic function. From this we will discuss what is quadratic function, what are the importance of quadratic function. Then from the graph of quadratic function we will try to uh, understand couple of terms like that. Then the graph of a quadratic function, we have some practice related to that quadratic function. Algebra for quadratic functions, some review. You need to review some of the things for working with the quadratic function. Then some application of the same thing. So we are going to discuss like this and this thing. Then where we will apply it, you will see it here. Then some practice homeworks. So this is the plan. Let's start. Let's put it here. So what is the form of quadratic function? You will see that the main form of the quadratic function is this: ax square plus bx plus c. This is the format of quadratic function. Ax square plus bx plus c. This is the form of quadratic function. And most important term here in the quadratic function is this term, ax square. Okay, this squared, x squared, this is the main clue for the quadratic function. Okay, if you see x squared, then you will automatically understand that okay, now this is a quadratic function. Okay, so this is the thing of quadratic function. We said that a cannot be equal to 0, so this a cannot be equal to 0, but b and c, they can be 0, no problem. So why a cannot be equal to 0? What is wrong with if a equal to 0? What happens? If a equal to 0, then this entire term becomes 0. Then this is bx plus c. And bx plus c is actually a linear function. Linear. Yeah, bx plus c. This is linear. So this function is quadratic mainly because of this term. So this ax square, this thing actually makes the function quadratic. Okay, this is the main reason. So now, try to locate which one is quadratic and which one is not quadratic from this following given examples. And I think you will very easily you will notice that x square, this one is quadratic. See, x square, this one is quadratic. There is x square, this is quadratic. Okay, you can see that x squared term, that is quadratic. And you can say, sir, where are the other terms here? Only x square. Yeah, only x square is also quadratic, no problem. We can write some more terms and we can just ignore them, no problem. So these three terms, they are quadratic. And this word came from quadratus, which means this is the Latin actually origin. Quadratus means to make square. So you see, basically our quadratic function, the origin is also related to some square. Okay, square, and x makes x squared. You know that. Okay, so this is the origin of this quadratic functions. Then, okay, where we will use this quadratic function? Let me bring all of them here. Where we will use this quadratic function? This is one application of quadratic function, business, money related questions. Actually, we will discuss these questions in detail in the application part. This is just we are giving you some clue, some hints, some very basic idea where we will use it. But you will see that the application of this math we will show you in the application discussion class. So this is one example, money related maths. We can use the quadratic function. Then there are more: rocket ships, footballs, cannonballs, etc. If something have, let me show you. If something comes with this kind of shape, if something comes with this kind of shape, then we can discuss it by quadratic function. You see, okay, let me tell you, this is interesting. So you know that this football player, Messi, Cristiano Ronaldo, they, when they kick on the ball, so they have, like, suppose this is the ball, some people, let me show. So let's say this is me. So when they kick, so then there is some goal post, and then ball enters there and we say, yay, goal. What happens there? The shape, the path of the ball is actually parabola, quadratic function graph. You will see that when you will draw the quadratic function graph, you will see the shape will be like this, like this shape, this shape, or down like this shape also it can come. And if something shape is like this, parabola shape, then we can actually discuss it by parabola, discuss it by the concept of this chapter, quadratic functions. You will see that we will discuss couple of tools by which you can analyze this kind of function. So we have many interesting application of quadratic function. Simply we can conclude it by this, and you can see money related problems and projectile related problem. Let me make this picture a little bit small. Let me make this picture a little bit small, or I can do it. I can do this also. Yeah. So this works. So this is the, as I said, this is the application of quadratic functions. We can use quadratic functions for this, for solving maths related to this. Projectile motion. Projectile motion means if you throw something from one point to another point. What can I throw now? Suppose this watch I can throw. See, if I throw it, it comes like this. It comes like this. It just dropped on the other side. Let me check my watch. Okay, I'll check it later. So so oh my god, if it is broken. No, it's not. So if something follows this path, this is called the parabola. This is the path of the quadratic functions, and this is actually the projectile motion also. This name actually came from that kind of motion, projectile. This is called projectile motion. If you throw something, just simply if you throw some rocks, some stones, if you throw it, then the motion will be like this. The motion will be like this. The motion, suppose from here you throw something, the motion will be like this. This is the projectile motion, and this projectile motion comes from the quadratic function. Okay, this comes from the quadratic function. And if you want to understand the motion, suppose how much where the ball is, this stone will hit, you can do it mathematically. You can understand it mathematically. So let's start it. Let's look. Let's look. First of all, couple of things about the quadratic function. Let me bring all of them. So what is the name of the graph of quadratic function? This is called parabola. The shape is parabola. This shape is called parabolic shape. This shape is called parabolic shape. This shape is called parabolic shape. What kind of symmetry does the parabola have? You will see that this is, if a parabola is here, suppose if a parabola is here, then it will have y-axis symmetry. Y-axis symmetry. But symmetry line, as you can see, symmetry line may shift from one place to another. This is if some standard quadratic function, if we draw, they will have y-axis symmetry. Okay, and sometimes the parabola can go downside also. Again, it will have the y-axis symmetry. Axis or axis will be y-axis symmetry. So it can go downward, it can go upward. So also. So the symmetry, what symmetry it will have? It will have y-axis symmetry. What is the name of this shape? What is the name of this shape? Name of this shape is parabola. Okay. Then intercepts. So in this figure, how many x-intercept we have? We have one x-intercept here, another x-intercept here, and there is one y-intercept. And in a parabola, actually, there is only one y-intercept. Only one y-intercept. But x-intercept can be, there can be one x-intercept, there can be zero x-intercept also. Suppose if I draw a parabola here, Suppose if I draw a parabola here, see there is no x-intercept, but this is a parabola. This is a parabola, but there is no x-intercept, only there is one y-intercept. So this is an example of 0 x-intercept. Okay, this is example of 0 x-intercept. Let me show you 1 x-intercept. Okay, suppose if I draw a parabola here, let me use another color, something different color. Okay, this one. If I draw a parabola here, yeah, so there will be just only one x-intercept here, just only this point. So one x-intercept is also possible, and two intercept already you can see. This is the two x-intercepts. So there can be 0 x-intercept, 1 x-intercept, or 2 x-intercepts. Okay, but y-intercept is just only one. Think about it. Why y-intercept can be just only one? Why y-intercept can be why y-intercept there can be just only one y-intercept? You can think about it. Or is it possible to get more y-intercept? You can see the intercepts are marked here. Vertex. Vertex means the turning point. What is the vertex here? This is the turning point. Let's use red color, or let's use black color now. So this is the vertex. This is called the vertex. This is the turning point. For this graph, suppose this is the vertex. For this graph, this is the vertex. Okay, this is the vertex. This is the turning point. Let me draw another one here. Suppose this is my graph. Suppose then vertex will be here. Vertex will be here, somewhat here. Vertex will be. See, the graph is increasing. The graph is increasing. The graph is increasing here. Then after the vertex, the graph will start decreasing. So this is the way by which you can understand which one is vertex. If some graph starts increasing, then at some point it will start decreasing, then this will be vertex. Or if some graph is decreasing, then after the vertex, the graph will start increasing. So this is how we understand which one is vertex. Okay, vertex is called turning point. And how we will understand, another way is, this is the maximum point of this graph. So this is the vertex, and for this kind of shape, this is the minimum point. Minimum point is the vertex. So this way also we can understand. And line of symmetry, already you have seen that there is a line of symmetry. For this graph, the line of symmetry is here. Yeah, for this graph, the line of symmetry is here. And we can say that x equal to 1. X equal to 1 is the line of symmetry here. X equals to 1. That means the vertex x value. From the vertex, x value is the line of symmetry. About this line, this side and that side of the graph is same. Exactly same. So we can say that this is the line of symmetry for this parabola. And for this one also we can draw a line of symmetry. We can draw a line of symmetry here. We can draw a line of symmetry here. For this graph also we can draw a line of symmetry here. For this graph also we can draw a line of symmetry here. Line of symmetry means a line for which the left and right side of the parabola is same. We can easily find it out from where? From the vertex x value. This is the vertex. Vertex x value means what? Let me explain this very clearly. If I ask you what is the coordinate of this point, this point is what? See, x equal to 1, y equal to minus 4. So this value is 1 comma minus 4. Then what is the line of symmetry here? You have to just look at the x value of the vertex. This line will be x equal to 1. This line will be x equal to 1. This is the line of symmetry for this function, for this parabola. Okay, so you have to go to the vertex. Vertex x value will be the line of symmetry. So yeah, now this is the practice. Try to find out the intercept and vertex, line of symmetry, etc., from this example. You try to do it, then we will show you the answer here, so that you can match. Okay, let's see. So as you can see that for the blue line, this is the blue line, our x-intercept is, see this point, -5 and -1, and then y-intercept is here, which is -2.5. Then line of symmetry, vertex is here, minus 3 comma 2. This is, but by the way, don't get confused, it looks like -1 is here, 2 3 4, it looks like that, but actually the scaling is not like this. The scaling changed a bit, so you have to be careful about that. This is actually -1, this is -2, this is -3, this is -4. So this middle line is the decimal value. This is 0.51, then 1.5 minus, of course all of them are minus. And line of symmetry is x equals to -3, because as you can see the vertex x value gives us the line of symmetry. So for the blue line we have the answer like this, and you can actually look at for other answers also. You can see, check the other answers similarly. And if you have questions, we can discuss it in the class also. Okay, give a try. Now let's discuss another very important thing about the working with the parenthesis. Parenthesis means bracket. Okay, parenthesis means this word. Parenthesis means bracket. This means bracket. So if we have x into 5 minus x, this is a review from algebra. If you see x into 5 minus x, so what will be, if you multiply, what will come here? X into 5, that means 5x, and x into x, that means x squared. So we can write it this way. That means what? That means if this is given to you, then how can you factor it? You factor it like, you can do the same thing again. You can take x common from this both terms, so then it will become x common. If you take x common from here, 5 will be remaining, and if you take x common from here, only x is remaining. So we have this. Okay, so we have this, and we actually have the, and the same thing goes with the other maths also here. We can multiply this and this, then we will get some bigger quadratic, and actually they are quadratic. By the way, the most important thing to notice here is this is quadratic. It looks like x into 5 minus x, it looks like, okay, there is no power, is not 2, but actually power is 2. It is in the multiplied form. It is in the multiplied form. So basically they are quadratic. This is why we are discussing it here, and this is important actually. So you see, this is this. And for this one, if you multiply x plus 2 and x minus 4, ultimately you will get something like this. Let me show you this one. So x plus 2 and x plus 2 and x minus x plus 2 and x minus 4. So if you first multiply with x, and this is actually, for some students this is very easy because you already have done this kind of math a lot. I'm just showing for not some, for most of you. Then we multiply it, x into x means x squared. So what I have done here is, first we have to multiply this x minus 4 by x, first number, then we have to multiply the same thing by 2, because this is the multiplication process. So first of all we will multiply this first term and this full, and then with this again we have to multiply the same thing. So x and x multiply, it becomes x squared. Then x into minus 4, it becomes minus 4x. Then 2 into x, it becomes twice x. Then 2 into minus 4, it becomes minus 8. Then we have x squared minus twice x minus 8, which is here. Now, this may sound funny, but actually our question is, if this is given, x squared minus twice x minus 8, can you factor it to this? That is important. That is the needed thing here. Yeah. So if x square minus twice x plus minus 8 is given, can you go back to these factors? We need to factor them for very interesting and useful purpose, which we will explain in the next page. Why we need to factor them, we will explain it. So suppose x square minus twice x minus 8 is given. How can you factor it? So first of all, you have to think about, okay, what two numbers I can break this 8, how can I break it down so that I get minus 2 by adding or subtracting the numbers? And you can do it this way: x squared, first write x squared, and this 8 can be divided into two parts like 4 and 2. And if I write minus 4 plus 2, then we get this minus 2. If we write minus 4 plus 2, then we will get this minus 2 also. Then we can give here x and give here x. This x and x came from where? This x and x came from the first term, x squared. And then the remaining thing is minus 8. I think you may have noticed that basically I have written this line here again. And this line I have written here. Same thing, see? This same thing. Then you can take just x common from here, which will be this line. And the next line is again come back to the question. X minus 4, just take x minus 4 common, then x plus 2 is remaining. That means you can go down or you can go up by using the same ladder. By using the same ladder. Or let me show you this part. So if you take x common from here, then from here if you take x common, then it becomes x minus 4, then plus 2. If you take x common, so it becomes x minus, if you take 2 common, then it becomes x minus 4. So you see x minus 4 common from this both place. So we can take x minus 4 from here. Then we can take, we can write the remaining thing. X is remaining here and plus 2 is remaining here. X minus 2 is already taken there. So this is the factor. So important thing here is, suppose if you see this line, you should be able to come to this line. And this will give us very important decision regarding quadratic function. Okay, this is called factoring. We are trying to factor it here. We are trying to factor it here. And actually, we have more examples of this. So this one, if we multiply, it will look like this. This one, if we multiply, it will look like this. This one, if we multiply, similar math, all of them, it will look like this if we multiply with each other. This is what we said that factoring. So you see, in this page, what you have seen is you have seen this kind of thing. And then if you multiply, we said that, okay, now you will get this. If you multiply this and this, then you will get this. But if this is given, then actually we can go to here, which is in this page. So you can actually factor them. We can actually factor them. And the process for factoring is we have to look at this second number. Any math, we have to factor this number first. From this to this number, suppose this is 20. 20 can be actually, in many ways we can write 20. 2 into 10 is 20. Then 4 into 5 is 20. Then what else? Is there any way? 1 into 20 is 20. Is there any other way? Let's check. So if we write 20, factor it. This is how we can factor it. Divisible by 2. Then we can write here 10. Then divisible by 2. We can write here 5. So yeah, there is no other way. So 1 into 20, 1 and 20, one combination. Another combination is 4 and 5. 4 into 5 equals to 20 again. Then 2 into 10, this is also 20. And then is there any other combination? 4, 10, 2. Yeah, it looks like these are the combination for the 20. Now, when you have the combination, you have to think about which combination you can use to get this minus 12, to get this number. Which combination? See, this combination, from this combination, if you add these two numbers, 20 plus 1, it becomes 21. 20 minus 1, it becomes 19. We are not getting 12. 4 plus 5, it gives us 9. 4 minus 5, it gives us minus 1. 5 minus 4, it gives us plus 1. Nothing works. But you see, this combination actually works. I am actually talking about the middle term factoring. middle term factoring. So this combination actually works, because if I give here minus 10 and minus 2, then actually we get minus 12. So let's use this combination here. If we write x squared, actually in different country you people have different way of factoring, so please feel free to use your, suppose in your country you may learn how to factor this kind of thing, you may learn it in another way, so please feel free to use your method, but you and we will come to the same decision, same answer at the end. Make sure that you come to the same answer. So x square minus 10x minus 2x plus 20. So this is then we can take x common from these first two terms, so it becomes x minus 10, and from the last two terms we can take minus 2 common, then it will become x. See, we have taken minus, so plus into minus equal to, now it will become minus, or you can think it this way, minus minus plus, this way also it will work. Now you see x minus 10 and x minus 10 is common everywhere, so x minus 10 comes here, then x minus 2. So we have got, this is the factor. Why we are factoring it? Why all of a sudden this is necessary? This is actually algebra. Do you understand? This is actually algebra review. This is not pre-calculus. This is a lower level thing. But why now we need it? The reason is for a couple of maths in the quadratic chapter, we actually needs to find out the factor to understand a very important thing, which is coming up in the next slide. So this way we can factor it. This way, the same process for all of them. Same process for all of them. Same process for all of them. So you give a try, then I will show you the answer. Or we can, we may practice some of this in the class also. Please let us know if you cannot factor them, or if your answer is different than our answers. Please let us know. Okay, so this is the factors. And let me give you quick hints. These factors, from these factors we will get actually x-intercept of the quadratic function. This will represent, we have picture of this kind of functions in the coming slides. This will represent a quadratic function, and these factors, they will represent the x-intercept. This is x minus 2, so the plus 2 will be 1 x-intercept, and this is x minus 10, so the plus 10 will become 1 x-intercept, which is here. Suppose x square minus 6x plus 5. What is the factor? What is the factor? If you do the factoring, what is the factor? Try to do it. If you do the factoring thing, you will see that this kind of thing will come. X minus 1 and x minus 5 will come. And if x minus 1 and x minus 5 comes, then the plus 1 and plus 5 will be the x-intercept. X minus 1 comes in the factor, x minus 5 comes in the factor, then plus 1 and plus 5 will be the x-intercept. So why we are factoring them? Why we needed them? Why all of a sudden we need to factor these quadratic functions? The reason is we need to understand the x-intercept of the function. This is the quadratic function, and this is the graph, exact graph of this quadratic function. And where is my x-intercept? This thing we will understand from the factor of this term. So the factor of this term is, this is x minus 1 and x minus 5. So 1 x-intercept will be, if you see minus 1, x minus 1, then plus 1 will be the x-intercept. This is x minus 5, so plus 5 will be x-intercept. And we have done it here actually. So what if you see plus, suppose if you see x plus 5 in your factor, that means minus 5 will be the x-intercept for that part. Okay, this is possible, minus 5, it can go to the minus 5, minus 5 also it can go. So why we are doing factoring? Because we are interested to understand where is the x-intercept. Yeah. And why for the minus 1, for the minus 5, why it is plus 1 plus 5? Because x minus 1 into x minus 5 equal to 0, then we can consider either this equal to 0 or that equal to 0. Yeah. This is also another important properties of algebraic product of two terms if they gives us 0. This is called zero product property or zero product rule. Let me give you what does this word means. This is the rule actually. This is a very fundamental rule in algebra. Eh, Suppose if I write 2 into, suppose just this is not true. Suppose if I write 2 into 3 equal to 0, is it possible? You know that 2 into 3 equal to what? 6, right? So if I say 2 into 3 equal to 0, it's not possible. How can it be possible? Either 2 into 0 I have to write, right? Then it becomes 0. Or I can write 0 into 3, then it will become 0, right? Or this is also possible. I can write 0 into 0. This is also can be 0. So if we have something like x minus 1 into x minus 5 equal to 0. So how can it be 0? How can this term and this term be 0? How can? Either x minus 1 must be 0 or x minus 5 must be 0. Or else it cannot be 0. Or else answer cannot be 0. Because it is multiply this into this. Any one of these two terms must be 0. Or both of them is 0. We do not know. That's why we considered, okay, maybe x minus 1 is 0. If x minus 1 is 0, then we will get x equal to 1. X minus 1 equal to 0, then 1 goes to the other side, we get plus 1. Or maybe x minus 5 equal to 0. X minus 5 equal to 0. X minus, then x equal to 5. Now you can ask me another question. You can say, sir, why we have to think at the first place, why I have to think that x square minus 6x plus 5 equal to 0? Why? Because in the function, you did not say that. You just gave a function. You said that fx equals to x square minus 6x plus 5. But why I have to think that this equal to 0? Why? The reason is, we are trying to find out the x-intercept. And x-intercept means y equal to 0. Fx means y. So fx equal to 0 means x square minus 6x minus 5 equal to 0. And to get the x-intercept, we have to write fx equal to 0 or y equal to 0. So y equal to 0 means this side equal to 0. So this is how we can actually proceed logically. Let me wrap it up nicely. So if some quadratic functions are given, we have to factor them. Why? To understand the x-intercept. That's why it is necessary. That's why it is necessary. Yeah, and if you put f of 1, if you put 1 in the question, answer will become 0. If they are x-intercept, and if you put it back in the question, answer will become 0. You can try. You can try. 1 here, 1 here. Let me show you one. Let me show you one. If you put 1 here, so 1 is equal to 1, minus 6 into 1 equal to 1, then plus 5, then what is coming? 1 plus 5 equal to 6, then minus 6, 6 minus 6 equal to 0. That means fx equal to 0. That means y equal to 0. So that means this value. Because this point is 1 comma 0. That means if you put 1 in the function, answer comes 0. That means if x value is 1, then at that point y value will be 0. This is what we understand from the x-intercept also. So there are, you can see there are a couple of things we understand. If we actually really try to dig a little bit deeper and try to understand, okay, what does it mean? Okay, what we get? If we get this, what does it mean? They actually mean a couple of things. For the 5, it will be same for the 5. It will be same for the 5. Okay, this is the last slide. So before I go to the last slide, you can actually ask me another question, another difficult question about here. You can say, sir, you are saying that fx equal to x square minus 6x plus 5, the graph of this function is this one. How do we know? Or why we have to trust you? So my suggestion is, do not trust me. You try to draw this graph. Then you will see actually this kind of thing. So how can you draw it? Think about some This is for yourself. This is actually you will need actually to understand this kind of thing just for future. Okay, x then fx, just like in our classical way, old way of drawing graph. Think, okay, if x value is 1, what happens? If x value is 0, what happens? If x value is -1, what happens? If x value is 2, what happens? So do put it here, do some calculation, put it. If you are interested, okay, then you can put it and you can draw it. You will see that this graph you will get. In future, we will actually draw them, and there are more techniques to draw this kind of graph. But at the beginning, you should actually try it in our classical or old way of drawing any graphs. Okay. So this is the introductory class on quadratic functions. This is the very basic beginning of the quadratic functions. That's why we will stop it here. We have more things coming up related to these quadratic functions in the coming classes. Yeah. In the meantime, the same thing. So graph by plotting points, find the vertex, line of symmetry for this function and this function. This is your work. And there is like x-intercepts by the factoring. So this is factoring maths. Factor them. Try to. These are the homeworks. You can try to factor them and try to graph these two functions. Okay. So this is the like practice work. You can just practice it. Uh, and if you cannot, if you face problems, you can tell us. We can try. So all right. Thank you all. Thank you very much. Thank you all for watching the video and for your effort. Have a good day. Bye.